Hello everybody and welcome to Task 1.1's video, which is the first video of Module 1 for Math 1. So in today's video, we're going to be addressing two learning targets. The first learning target is I can create a table or graph for a situation that can be modeled as an arithmetic sequence. So the goal here is going to be to create, so make a table or graph for a situation that we are going to call arithmetic. And the second learning target of today is that we are going to be able to create a table or graph for a situation that can be modeled as a geometric sequence. Now, as we go through this set of notes, we're also going to be introducing some new vocabulary words, and we're really going to be looking at making connections between different representations. So we're going to start here with a visual pattern. In this picture, the first thing we're going to do is think about how we see the pattern growing. So at this point, if you wanted to pause the video and think about how you see it growing, there are lots of different right answers. But I'm going to go ahead and share one of the ways that students often describe this pattern as growing as we go through. So one of the ways that students often see this pattern growing is they see this center dot, and then in the next picture, they see that this center dot remains the same, and then there is one dot in each corner. So they see the addition of these four dots. Then in the next picture, they see one center dot, and then they see almost like arms growing, two dots growing from each arm. Now, like I said, there are lots of different ways that students see this growing. One of the other ways I've often heard described is almost like students see this as adding a square each time. So they see it as starting with a center dot and then having a center dot with a square around it, and then having a center dot with two squares around it. And they kind of see each of those squares as being the additional layer of dots. No matter how you visualize this, the way you might want to describe this pattern is that you are adding four dots each time. So we could say here for describe the pattern, you start with one dot, and that would be the one in the center, and then you add four dots each time, which could be you added these four and then you added arms that have four because you added another layer to each of those arms, but you're basically adding four each time. Now, in the words here, we're going to see this is being described as at the beginning, and then at 1 minute and at 2 minutes. The next thing we're going to do is try to visualize how this pattern is growing by drawing minute 3 and deciding how many total dots are at minute 3. Now, based on the pattern, I would expect that at minute 3, we would still have a center dot, but then we would have arms with, instead of 2 dots, 3 dots on each arm. Which means my total number of dots would be the one that's in the middle plus I have 4 arms with 3 dots each. So to show that there are 3 each, I'm using multiplication here. Now that means I have 1 plus 4 times 3 is 12. So I have a total of 13 dots. Now you could also have figured that out by simply counting. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the 13th dot is in the middle. Now, one of the reasons you might want to think about it more as this kind of a pattern, you have the one in the middle plus 4 arms with 3 dots each, is because the following question here says, how many total dots are in minute 100? Now, I don't know about you, but I do not want to have to draw 100 pictures to figure this out. So by observing the pattern, what I'm noticing is that after 1 minute, there's 1 dot in each arm. After 2 minutes, there are 2 dots in each arm. And after 3 minutes, there are 3 dots in each arm. If I follow this pattern, then I would expect for minute 100 to find 1 dot in the middle, and then I would expect there to be 100 dots in each arm, which means instead of drawing it with dots, I'm actually going to write the number 100 because I don't really want to draw 400 dots. So I would expect it to look something like this. What that means is that I can find the total here by starting with that 1 dot in the middle and adding 4 arms that each have 100 dots. Now that means that if I simplify this, 4 times 100 is 400, so I would have 1 plus 400, which means I would expect figure 100 to have 401 dots. Now we're going through this because it's really important in mathematics to visualize your thinking. Most of the patterns that you find visually are actually a great way to start thinking about the problem mathematically. So if we start with a visual pattern, you can see pretty quickly we can start to use some addition and some multiplication to predict what's going to happen in the future. Here's where we're going to lead into our first learning target. So we're going to start by making a table of values. Now in a table, there are a few important features you need to include. The first thing that always needs to be in a table are labels. Now when we make our labels, here's how we're going to do that. The number of minutes, so the at the beginning, the 1 minute, and the 2 minutes is going to be in the left-hand column of the table. Now the left-hand column of the table is always the input values. And in this case, we're going to call the input values the number of minutes. We also need a set of output values. So in the right side column, we're going to label these the output values. And the output values are going to be the total number of dots. So let's see if we can use the pattern that we found to represent this value. So for the number of minutes, because it says here we're starting at the beginning, my first minutes is going to be 0. Then I'm going to have 1 minute, 2 minutes. I know the answer for 3 minutes. I'm going to include that. And then I'm going to leave a dot, 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 which means there's some space here. And I'm going to include the answer for 100 minutes because that's another value that I calculated. Now for my output values, I'm going to put the number of dots. So at the beginning, there was 1 dot. Then there were 5 dots. Then there were 9 dots. So 2, 4, 6, 8, 9 is in the middle. For minute number 3, I would have 13 dots. And for minute number 100, I would have 401 dots. And again, there's a big gap here. So the other numbers are going in order 0, 1, 2, 3, and then there's a big space. And I want to indicate that by putting a dot, dot, dot in the table. Now, the other part that we're going to be looking at here is making a graph of these values. So if we want to make a graph is going to have both an X and a Y axis. The input values go on the X axis. So this is going to be on the X axis on the graph, which is here at the bottom. Now, in order to draw a really good graph, just like my table has labels, I want my graph to have labels. So at the bottom here, I would label this the number of minutes. And again, that's always going to be the left-hand column is the x-axis. Now, the total number of dots are going to be what's called the y-axis, which is the one that goes up and down. So I'm going to graph here the y-axis, and I'm going to again label this just like a good table has labels, a good graph has labels. So I'm going to label this side the total number of dots. Now, we also want to label with numbers. So the lowest number on the x-axis is 0, and then 1, 2, and 3. And because the 100 is so far outside of this kind of set of numbers, I'm not going to graph this one. This is just sort of extra for fun to challenge ourselves. So I'm really only going to graph the top part of this table. So the 0 would be right here in the middle, and then we've got 1, 2, and 3. And the important thing here is that these numbers are evenly spaced. So if I wanted to do 0 and then 2, I would have to do 4 next, and 6 and 8. If you decide you're going to count by ones, you have to count by ones. If you decide you're going to count by twos, you have to count by twos. Now on the y-axis, I want my numbers to go up to at least 13. So if I count the lines here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, which means there's not enough lines to get to 13. So instead of counting by ones, I might decide to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. You'll notice that if I decide to count by twos, I have to count by two the whole time. Now on this axis, the lowest numbers are always here, which is what we call the origin, and they get bigger going to the right. And the lowest numbers are always here at the bottom, and they get bigger going up towards the top. Now I'm going to graph. So to graph this point, which is 0 and 1, I would find the 0 on the x-axis and the 1 on the y-axis. Now the 1 is in between 0 and 2, so it would go right here. Then I would find the 1 on the x-axis and the 5 on the y-axis, which is in between 4 and 6. Then I would find the 2 on the x-axis and go up to the 9 on the y-axis. And lastly, I would find the 3 on the x-axis and go up to the 13, which is in between 12 and 14 on the y-axis. Now, one thing you might notice is that these points seem to make a line. So a lot of students are really tempted to draw a line. We are not going to draw a line. And let's kind of talk about why. When we draw a line, what that means is that there are values in between the dots, and that's why we're connecting them. What that would mean is that there must have been a picture that we called minute 1/2 or minute 1.5. Well, we know that our pictures go from 0 to 1 to 2. They jump. There is no half of a minute. So because there's no half of a minute, and because we're jumping from one value to the next value without moving smoothly, we're not going to connect the dots here. And that's an important thing, because connecting the dots means a different thing mathematically. It means there are half numbers, and that this is something that's growing gradually, whereas we know we're not going to add half a dot ever, which we're just going to come out with a full dot. So that means that we're not going to connect the dots on our graph either. Now let's look at a couple patterns and connections here. We said in our words, we started with one dot. And what you're going to notice is that our table started with a 1, and our graph started with a y value of 1. So there's a connection here. The picture started with 1, the table's output values started with 1, the graph's output values started with 1. We also said we added 4 dots each time. Now if we look at the table, to go from 1 to 5, we add 4. To go from 5 to 9, we add 4. To go from 9 to 13, we add 4. So this idea of adding 4 dots each time shows up in the table as well when we look at the pattern. In the graph, we can see that same pattern because the next y value on this graph is 5. And if we count here, to go from 1 to 5, we go up 4. To go from 5 to 9, we go up 4. To go from 9 to 13, we go up 4. So we can see this same pattern of adding 4 over and over and over again. And we can see it in our equation as well. We add 4 3 times. We add 4 100 times, depending on the number of minutes. Now, this idea of connecting the way we see a pattern between a visual, a table, and a graph is going to be a really important idea in this unit. Let's take a look at the second part of this task. So we have a different pattern here. Use the image to show how you see the pattern growing. This might be a time where you want to pause the video and think about it for yourself. One of the ways that students often explain if they see this pattern growing is that the original shape is like a triangle. There are 3 corners. And at the beginning, there's 1 dot in each corner. Then they see that there are 2 dots in each corner. Then they see that there are 4 dots in each corner. Then they see 8 dots in each corner. And then they see 16 dots in each corner. So what they're noticing is each corner has 1, and then 2, and then 4, and then 8, and then 16 in each corner, which means the number of dots that they're seeing in each corner is multiplying by 2. And that applies for every corner. So to describe the pattern, they say the number of dots starts with 1 in each corner. And then they say the number of dots in each corner doubles, which means multiply by 2, each minute. Now that means that the total number of dots here is 3, and then we have 2 in each corner, so there's 6, and then we have 4 in each corner, so there's 12, and then we have 8 in each corner, so there's 24, and then we have 16 in each corner, so there's 48. So the total number of dots gets multiplied by 2 in each corner as well. Now here, we know what happens up until minute 4, but how many dots would you expect at minute 5? Well, at minute 5, I would expect 32 dots in each corner. Now, I don't really want to draw any dots here. That would take a really long time, but I would expect there to be 3 sets of 32 dots. So I would do 32 times 3, which means I get 96 dots total. Once again, we want to make a table of values and make a graph, because that's our learning target for the day, is being able to make a table of values and make a graph. And just like before, a table of values needs to have labels. So just like in our previous example, since this is at the beginning, 1 minute, 2 minutes, 3 minutes, 4 minutes, and now we also know 5 minutes, we're going to call the number of minutes our inputs in our table. And just like before, we're going to use the number of dots as the outputs in our table. So this starts with at the beginning, there's 0 minutes, and then 1 minute, 2 minutes, 3 minutes, 4 minutes, and 5 minutes. Those are the minutes I know the total for. At the beginning, there are 3 dots, then there are 6, then there are 12, 24, 48, and then I calculated that there are 96 dots in minute 5. Now I want to make a graph. So just like before in our previous example, a graph should also have labels, which means this x-axis here at the bottom goes with the left side column, which tells me I should label the bottom number of minutes. Now the y-axis goes on the vertical side of the graph, which is here. So I'm going to label this one number of dots. On the x-axis, my numbers are going to go from 0 to 5, and there's plenty of lines to do that. So 0 would be in the corner, and then 1, 2, 3, 4, 5. On the y-axis, however, my numbers need to go up to 96. Now, just like before, we only have 10 lines, and so counting by 2s will only get me to 20. I need to count by something bigger than 2 so that I can get all the way up to 96. So to do that, I'm going to count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now to graph this information, I'm going to start with 0, 3. So I'm going to find the 0 on the x and the 3 on the y. Now 3 is going to be really close to 0 here. It's in between 0 and 10. Then I'm going to use the 1 and the 6. So 1 on the x, 6 on the y, which is a little bit more than halfway to 10. Then I'm going to do 2, 12, which is a little bit past 10. 3, 24, which is about halfway between 20 and 30. 4, 48, which is pretty close to 50. And then 5, 96, which is pretty close to 100. Now, just like in our previous problem, we're not going to connect the dots. And the reason we're not going to connect is you're never going to have half of a dot in your pictures, so you don't want to connect this to show that you're growing gradually. You're just jumping from one picture to the next picture. The other thing you should notice here is that this is not a straight line. This is actually a very curvy graph, and it shows us this nice curve here. So now we're going to think about the pattern that we saw. Just like we saw in the previous problem, there was a connection between the pattern in the picture and the pattern in the table. So we said we start with 1 dot in each corner, which means 3 dots total. And you'll notice that in the table, we're still starting with 3 dots total, and on the graph, we're still starting with a y value of 3. The other pattern you should see here is that the number of dots doubles each minute. Now, if we look for that pattern in the table, we're going to see it in the output values. To go from 3 to 6, we multiply by 2. To go from 6 to 12, we multiply by 2. From 12 to 24, we multiply by 2. 24 to 48, we multiply by 2. And 48 to 96, we multiply by 2. So what that tells me is that that pattern I saw in my picture where the number of dots doubled is still a pattern I can see on my table as well. Let's go ahead and give these types of patterns some vocabulary words that we can use to describe them. The first pattern we looked at today is what we call an arithmetic sequence. An arithmetic sequence has a pattern where we are adding or subtracting the same amount each time. So what you'll notice is that in this first problem, we were adding 4 every time, and we could see that on our table as well. So the common difference is the word we give to the number being added or subtracted each time. In the example that we looked at before, we would say our common difference was +4. So that's the vocabulary for that common difference. In the graph of an arithmetic sequence, it's going to look like a straight line. So when we looked at our points on our graph in this first example, they lined up in a straight line. By contrast, the second pattern that we looked at today is what we would call a geometric sequence. Now, in this case, the geometric sequence has a multiplying or dividing pattern. If you think about our second problem, when we looked at how this pattern was growing, we weren't adding the same number and over again. We were multiplying by the same number over and over again. This kind of pattern does not have a common difference. It has what we call a common ratio, which is the number being multiplied or divided each time. In the example we looked at today, we would say that the common ratio is times 2. The graph of a geometric sequence will look like a curve. So if you looked at this graph, you'll notice the points do not line up in a straight line. They make a curved shape on the graph. What we are going to ask you to do moving forward is look at a table, look at a graph, and decide if that's a geometric sequence or arithmetic. And to do that, you would look at the pattern. Are we adding and subtracting or multiplying or dividing? And you would also then be asked to find the common difference or common ratio. So what is the pattern? Do you see a +4 or a +2 or a ×2 or a ×3? All right, thank you guys so much for watching, and I look forward to seeing you soon.